All right, so we're going to start talking about sine, cosine, and tangent on the unit circle. And I'm going to get right to it. The cosine on any angle in the unit circle, to get the cosine of that angle, you would find the x-coordinate. And the reason it's the x-coordinate is because from SOHCAHTOA, you might remember that cosine is the adjacent side of a right triangle over the hypotenuse. On a unit circle, that ends up being the x-coordinate because x is horizontal. So, and the hypotenuse is 1 on a unit circle because that's the radius, and the radius is always 1. So x divided by 1, adjacent over hypotenuse, is just x. Similarly, on the unit circle, the sine of the angle is the y-coordinate because that's opposite over hypotenuse, which is y, and the vertical over 1, which is y. And tangent, since tangent is opposite over adjacent, TOA, that's going to be y over x. So I want you to know these three facts. Cosine is x, sine is y, tangent is x over y. Y over x, I almost said that wrong. Cosine is x, sine is y, tangent is y over x, y over x. Those three are important facts. So let's get right into it. Now remember, I had filled out my own unit circle on a previous video. So you can either use one that you made similar to mine, or you can use a printed out one or refer to one online. We want to find exact values. So if I want to know what the cosine of 210 is, and I have done this, then I can refer to my unit circle and say, all right, cosine of 210. I'm going to go to 210 degrees, and I have a coordinate negative square root of 3 over 2, negative 1/2. Since the cosine is x, then at that coordinate, it's negative square root of 3 over 2 and negative 1/2. Well, I just want to report the x value. So the cosine of 210 is the negative square root of 3 over 2. And I'm done. I don't have to solve anything. It's just reporting the x value for cosine. I want to show you, though, on a calculator what you can do. And I love using the calculator, so I'm going to use it whenever I can. So on Desmos or your TI calculator, there are two modes that you can use. You can use a degree or radian. So on Desmos, if you want to make sure if you're in degree or radian, you will go to graph settings, and the default on this particular one is radians. So I want to change that to degrees first. Now, since the degree was 210, I will type in COS, just the letter COS, and use some parentheses if you'd like, and just do 210. And notice that it gives you negative 0.866. And our answer was negative square root of 3 over 2. Now let's see if those are the same thing. Negative SQRT 3, right arrow, divided by 2. See how those are exactly the same decimal, but we want to report the fraction here. This won't convert to a fraction because it's irrational. So you have to know this fact. You have to know that coordinate. So that's just to kind of prove that it works. I'm not going to sit there and do it with every one. The cosine of 210 is negative square root of 3 over 2. Now let's look at the sine of negative 330. We don't have negative angles on here, so we do have to get a coterminal angle, which means we have to add 360 degrees to that number. And negative 330 plus 360 is 30 degrees. So I really want to find sine of 30 degrees. What is sine of 30 degrees? Well, we can go to our unit circle. At 30 degrees, my coordinate is square root of 3 over 2, comma 1/2. Since the sine value is the y, then I want to report the y value. So since the y value is 1/2, sine of negative 330 degrees is also 1/2. And I'll check this again with a calculator. You just type SIN, parentheses, negative 330, since I'm in degree mode, and that gives me 0.5. I know that 0.5 is 1/2, so we are good to go. All right, example 3. What is the sine of pi over 2? pi over 2 is at 90 degrees. That coordinate is 0, 1. Sine, again, is the y value. So the sine of pi over 2 should be exactly 1. And I'll check this one. This is the last one I'll check with the calculator. Then we'll just go from the unit circle. So now pi over 2 is a radian. So I want to go back into my mode and change it to radians. And I would type SIN parentheses PI divided by 2, close parentheses, and it gives me the value of exactly 1. So I have my answer. All right, so I'm going to let go of the calculator and just do a few more without checking them. And you are welcome to check them on a calculator if you want. Just remember to, if it's radian, make sure your mode's set to radian. If it's degree, make sure your mode's set to degree. All right, cosine of 7 pi over 3. Let's see if I have 7 pi over 3 on the unit circle. All right, 7 pi over 3. Doesn't look like I have it. So that means that I have to get equivalent coterminal angle with that. So since that's in radians, I actually want to make sure that I subtract, that's going to be more than 360 degrees. So I want to subtract 360. But remember, 360 degrees is equal to 2 pi radians. So I really want to subtract 2 pi. Well, 2 pi is, you have to have the fraction in terms of the same denominator. So 7 pi over 3, what divided by 3 is equal to 2? That's going to be 6. So 6 pi over 3 is equivalent to 2 pi. Now you can subtract the 7 pi and the 6 pi, and that's 1 pi over 3. Now let's see if we have pi over 3. We do. So at that coordinate, pi over 3, you got 1/2 and the square root of 3 over 2. Well, cosine is the x value. So since the x value is 1/2, the cosine of 7 pi over 3 is equal to 1/2, positive 1/2. All right, let's do a couple more together, just so you can get the idea. These are tangents. These are going to be y divided by x. So tan of 150. Now I do have 150 on the unit circle. That is 5 pi over 6. That is negative square root of 3 over 2, comma 1/2. So I have my coordinate. Now tangent is going to require a little bit of reducing, because tangent is the y divided by the x. So I want to actually utilize both of these. I'm going to do 1/2 divided by the square root of 3 over 2. Now when you're dividing two fractions, what you want to do is you want to rewrite it as a multiplication problem. And you want to multiply the top fraction by the reciprocal of the bottom fraction, which means you want to flip it. So you want to say times 2 over, well, negative 2 over the square root of 3. You can put the negative on top or the bottom. I tend to keep it on the top. Now what's going to happen here is these 2's will cancel out. So it's negative 1 over the square root of 3. Some math teachers would like you to rationalize the denominator. And to do that, we'll take the, since you have a square root on the denominator, our goal is to get rid of all the radical symbols on the denominator. You do that by multiplying that fraction by the same square root that's on the denominator. It's going to cancel the square roots here out, because the square root of 3 times the square root of 3 is the square root of 9, which is equal to 3. So becomes on the numerator negative 1 times the square root of 3 over 3, and we don't need that negative 1, that 1. So it's really just negative square root of 3 over 3. So that's actually the same thing as negative 1 over square root of 3. It's just more preferred to write it like this. So the tan of 150 is negative square root of 3 over 3. And let's wrap it up with this last one, the tan of 11 pi over 6. 11 pi over 6. On the unit circle, I do have 11 pi over 6. That coordinate is the square root of 3 over 2 comma negative 1/2. Square root of 3 over 2 comma negative 1/2 is very similar to this one. We're still doing y divided by x. So I want to do, since that's y, this is x, it's really this, it's going to be the same answer because negative 1/2 over the square root of 3 over 2, you're going to get the same decimal that this would be. And it doesn't matter where the negative is. And this one has the negative on the denominator fraction, this one has the negative on the numerator, but it's the same thing. It's negative 1/2 times 2 over the square root of 3. 2's cancel out, and you get negative 1 over the square root of 3, which will turn into negative square root of 3 over 3. So you get the same thing. Tan of these two, even though they're in different spots in the unit circle, you end up getting the same thing. That happens sometimes. All right, hopefully those examples were enough. The next example, I want you to try some of these on your own. So I'm going to stop this video so it's not too long, and then you can use the next example to try some for your own before you get into the